So I was particularly interested in learning more about the terrible earthquake of February 6th that devastated so much of southeastern Turkey and northwestern Syria. This is there's three types of faults, and one of them is where the plates move together and one goes over the other, and the other one is where the plates move apart and opens up a hole or a rift. And then the third type, which is the type that the February 6th earthquake was, is called strike slip. So the crust is moving past each other. And so this was a very large event. There were actually two events, magnitude 7.8 and 7.5. There's about 16 magnitude 7 or higher events per year. And usually they occur in regions where it doesn't really bother anybody, out in the middle of the ocean or some uninhabited region. But these two occurred in a very densely populated area, and an area that has suffered a lot of disruption because of the Syrian civil war, and that has also suffered from lax construction, where the buildings were not built to withstand a magnitude 7 plus earthquake. So it was a perfect storm that led to this tragedy. But what's happening in this part of the world is it's what we call a plate collision, where in this case Arabia is moving north and Turkey is in its way. And so Turkey is being squeezed to the west. And that sets up a situation where the crust of Turkey is moving to the west as Arabia moves to the north, and that makes a strike slip. I don't know if you're going to see that. It makes a strike slip like this. We call this a left lateral. Now, the average over time, this strike slip fault is maybe, a half an inch a year, which if this motion had been a half an inch, it would not have caused anything like this. Earthquake magnitudes scale with the amount of displacement. If you have a very small amount of displacement, it's a very small earthquake. If you have, several meters or many feet of displacement, that's going to be a huge earthquake. And that's what happened here. So we had the situation where the fault is moving time averaged at maybe an inch a year, if that. But it all of a sudden, that motion was not continuous, so it would stick. The friction on the fault caused it to stick. And so that, what we call strain, built up until suddenly it just broke loose and it moved, meters. And that caused the terrible earthquake. And you have these big, magnitude 7 earthquakes on these strike slip faults every once in a while in regions where you get that frictional sticking. One of the big problems with an earthquake is the natural gas lines rupture. So if you rupture your natural gas lines, you get gas coming out, it can cause a fire, right? So what happened in San Francisco in 1906 was the earthquake destroyed a bunch of buildings, but then the fire got going, and that destroyed a lot more buildings. So if you can stop the natural gas flow a second before the earthquake, you can greatly reduce the fire hazard. And in fact, there's, an earthquake sends out 4 different kinds of waves. And the weakest one shows up first. So if you have an algorithm that'll say, okay, it's called a P wave. The P wave was this high, that means the S wave, which is not the S wave, but the surface waves, which are going to do the main damage, those are going to be this high, and we need to shut off the natural gas. So you get, depending on how close the earthquake is, the farther away, these waves travel at different speeds. So if the earthquake is on the other side of the Pacific, you get, a minute between the P wave, the S wave, and the surface wave. But if it's 2 yards away from where it is, you get no time. So you sort of have to go, okay, we got to have a very rapid response thing, which I think they're doing in Los Angeles, because that's something that you can do, And in fact, iPhones can be used as shake meters. They can pick up the shaking, right? And so I think there's a software you can put on your phone to pick up an earthquake. I mean, the social media has got to be very important in terms of communicating, right? All the phone lines are down, or even if they're not down, the electricity's gone. So how do you charge your phone? I mean, I think that the issue for people that live in an earthquake zone is, are you ready for a big one? And what does that mean? Well, I mean, you're going to be without water maybe, you're going to be without food maybe, you're going to be without electricity. If this earthquake comes and you're in bed, can you get out of your bedroom? An earthquake might shift your house so that the door won't open. Have you got a way to get out either through the window or busting down that door that will let you get out of a burning house? You have to think about these things.